Hey, what's up YouTube? It's Joey Troy here. Today we're going to build the future of astrophotography and EAA, electronic assisted astronomy, together. It's not just me, it's you too. So let's go. Okay, we're talking about building the future of astrophotography and EAA, electronic assisted astronomy. So how are we going to build these things and what the heck am I talking about? So in 2022, I created what was the Open Astro Initiative. It's openastro.net. You can go to the website and check it out. Essentially what I did is I built custom images of Open Astro software such as Indy and Indigo and got them to work with these devices. So things like StellarMate, things like Astroberry, things like Indigo Sky, and taking advantage of like the power ports that are on these devices from ZWO. So that was the Open Astro Initiative, and I've been trying like heck to get ASCOM to run on these things. So if you've kept up with me, I eventually got ASCOM to run on one of these devices, essentially installing Linux on here and then using these USB ports right here to basically plug in your Astro hardware, right? So we'd plug in like a camera and a filter wheel and your mount and all that other stuff. And then basically I used a program called Virtual here that takes the USB ports and then pumps them out through the network. And then essentially you install a client on Windows, and then the devices that you plug in here show up on Windows on the device manager, and then you can install like ASCOM and the ASCOM drivers from ZWO or whoever your vendor is. It worked, but it wasn't great, and it wasn't the best solution I've ever used, right? It was pretty terrible. So what I've done is I've created AlpacaBridge using AI. The words that no one wants to hear. I don't want to hear anything about AI and building software. Well, guess what? I built software and it works. And I can actually install it on a Raspberry Pi and control it with Nina and PhD2. Now, for the record, Nina and PhD2 don't support everything out of Alpaca World. One thing is PhD2 doesn't support Alpaca at all. So I'm actually working to write a update to PhD2, and I'm working with the vendors or not the vendors, but the open source developers at PhD2 to get it to work. I'm still testing it out and making sure it all runs. And then for Nina, I'm implementing what's called image bytes. So when you take a picture, like with a ZWO camera, and that picture gets pushed across with Alpaca, which is created by ASCOM, they use what's called image array. And what that does is it takes every single pixel from the picture that you take and essentially push it across. So what I've developed is essentially a working system, and still working to get Nina and also PhD2 to completely support Alpaca from the get-go. However, where I need your help is I need you to help build drivers for AlpacaBridge so we can build the future together of Alpaca. By default, if anybody knows Alpaca is essentially taking, in this case, we'll just call this a camera. We won't call this a ZWO camera, even though it says ZWO on it. But what we'll say is that this is a camera. And the goal of what Alpaca created was to essentially put Alpaca in this device. So you don't need to install any drivers on Windows anymore. You would just plug this into your network and connect to it because it's running Alpaca. What I've done with AlpacaBridge is created Alpaca Core and Alpaca HTTP, which are part of the bridge. Essentially, the core is all the API for Alpaca and drivers that I'm building with AI, and Alpaca HTTP, which we're using to basically communicate on the network to say like, hey, I'm a camera, I'm here, come talk to me, and then Nina connects to it. So essentially what we're doing is we're taking Nina on a Windows laptop and connecting it to a Raspberry, well, that's not a Raspberry Pi, that's a rock chip, a Raspberry Pi, and essentially able to use it. Now, what's neat about AlpacaBridge is you don't need to run on a Raspberry Pi. You can install it on a Nook. You can use Windows. You can install it on a Mac. So I have over here a little Mac Mini off to the side. So you could use a Mac Mini at the mount if you wanted to. It's really up to you on where you want to install it, but essentially I've designed the software to work on all operating systems, just like Alpaca works on all operating systems, and essentially allowing you to choose what application you want to use. So with that, let's jump into the video, watch me build a driver so you can learn how to build a driver, and then you can build one too. So let's go. Okay, so we're getting ready to build, and you can build this AlpacaBridge on Windows, you can build it on Linux, and you can build it on Mac. So it works on all platforms. It's completely OS agnostic. So it doesn't matter if you want to use a Mac Mini, it doesn't matter if you want to use a Nook, it doesn't matter if you want to use a Raspberry Pi. You can use any device that you want and essentially just install the software, and then basically once you compile the software, it'll build the drivers for your hardware. And I'll show you all this. We'll go step by step. But the first thing that we're going to do is build a driver. So the first thing that I'm going to be using is GitHub Desktop. I've already connected and downloaded the repository, but the repository is here at AlpacaBridge. Give it a second here. So this is basically essentially the repository. And then I essentially downloaded it with GitHub Desktop with my account. My suggestion for you is if you're building it, what you want to do is fork the repository to yourself. So you'll set up an account. It's all free with GitHub. You can pay for extra accounts with extra features if you want, but you can use it for free. And essentially you can fork the repository, which means you're taking like basically a copy of it and moving it to your own area within GitHub and basically working on it. So down in the description, I'll have links to understand GitHub, GitHub Desktop, and all the different tools that I'm working with, just to give you a better overview, because I'm really going to be just kind of going in and getting this done quickly. So essentially I have AlpacaBridge, and then in here I've created a new branch called Feature ZWO EFW, which is electronic filter wheel, right? Because we're going to build a driver that's going to be Alpaca compliant to work with this, because there is no driver. There is no driver that's made for Alpaca, because ZWO didn't release an Alpaca driver. They only do ASCOM, and then they leave it up to these other organizations like Indie and Indigo to build their own drivers. So in here, I've got it all downloaded and ready to go. So we've got the new branch. The first thing that we have to do is download the SDK, which I've already done. So you can just go to ZWO and SDK, and then you can just click here and download the SDK for ZWO. You don't need to worry about building anything for ZWO, because I'm just about done building everything for them. I should be getting my hands on a mount pretty soon. The AM5N, I believe. A buddy's going to let me borrow it so I can build drivers for it. So I need to add that onto AlpacaBridge. And in here, I have that under the issues. So stuff that I'm working on right now, I'm going to be working on the electronic filter wheel. And then I also have a Skywatcher EQ6 that I was gifted to me so I could build a driver, and then I'm going to gift it away to somebody else local, because it's 80 pounds to ship. It's too much to ship externally. So I'd love to offer that up to people, but it's just too much of a pain in the butt to ship 80 pounds. So I'm going to just give it away to somebody who's local here in the club with the Albuquerque Astronomical Society. So in here, you just go to others and then developers, and then you can download the SDKs. Again, I've already built a driver for the ASI cameras. So all the cameras now work and are Alpaca. For Alpaca, I've done the same thing with the electronic autofocuser and the CAA. And then I wanted to do a demo on YouTube on how to build a driver for the electronic filter wheel. So essentially download it, and it comes downloaded. So in here, if I go to downloads, I've got the electronic filter wheel. I've already extracted it. So here's the files it comes with extraction. So there's a Linux Mac SDK and a Windows SDK. So you can build for those two different platforms. So I'm going to just rename this file EFW for electronic filter wheel. And then I'm going to open up a new Finder window. And then in here, I'm going to swing over to GitHub, and then AlpacaBridge, and then Alpaca Core. And inside Alpaca Core, there's information in here. There's information on the on Alpaca Bridge on the website. There's basically information in here about understanding how this all works. So if you go through here, I've got links to all the different files and how to do everything. So you'll want to go through all this so you can understand how to build drivers and stuff like that. But essentially what we're going to do is we're going to put the SDK into the external folder, and then it's going to use that external folder as our standing place for all our SDKs to build drivers. So in here, if I go to ZWO, I can just drag that folder over. So where's my other window? There it is. So I can go in here and drag my electronic filter wheel in here, and then I can also drag the Windows code in here as well. So we've got all the code in here that we need. So we'll go ahead and just close those windows for now. And then we'll minimize this. And then I'm going to go ahead and open up Cursor. Inside Cursor, once you open it up, you can open up a project. So I'm going to, in here, I'm going to go to Documents, and then GitHub, and then AlpacaBridge, and then open that up. So now basically I'm inside Cursor, so I can work on it. I see all the files, I got core and all that, and everything's in here. So at this point, we're just about ready to start building a driver for this. So what I need to do is get the file location of where we're going to be building the driver. So I'm going to go in here to Codex, and then it'll load, and I'm just going to say I want to build a new driver for the ZWO electronic filter wheel, and need your help because I can't do this. It's going to do it. So please read the file at agents. So basically I've created an agent file because this is an agent that can read the file, and in there's all the instructions it needs to build the driver. We don't have to tell it anything except read the agent's file to build the driver. It'll build the driver. It'll do everything that needs to happen. And then we're going to specify the directory where the SDK is. The SDK for the electronic filter wheel is located in Documents, GitHub, and then AlpacaBridge. If I could just spell, that would be amazing. Bridge. And then Alpaca Core. And then it's in the external folder. And then it's going to be in the ZWO folder. And then in there, it's going to be in the electronic filter wheel folder. And then we're going to hit enter. I'm going to pause the video because I'm using, just so you're aware, I'm using Codex 5.2, and I'm using medium, so it takes a little longer to think. You can put it on lower, but I wouldn't recommend it. The higher up it goes, it does take longer. It does consume more tokens to do this, but it's really, really good. So I'm just going to pause the video on these sections, and then I'll just get to the next spot. So I'm going to go ahead and execute this and then let it do its thing. Okay, so I paused it and I'm unpaused the video. So we're recording again here, and you can see it's about 12:21. So I paused at 12:15. So in roughly about 6 minutes, it basically inspected the whole repository, went through all the rules and all the guidelines of how it's supposed to build the driver, and essentially now it's building the driver out. So it inspected the existing ZWO driver and the patterns of how everything works and the API, and understanding the whole repository. So essentially at this point, the AI is basically understanding how everything's working, and now they're implementing a ZWO electronic filter wheel SDK wrapper. So essentially we can communicate with the software, or excuse me, communicate with the hardware through the driver, and then basically use the framework so we can communicate with it using Nina or other things, and then basically it will meet the standards when we're done building it. So we still have a lot of work to do. It takes time, but as you can see, it's building out the code and essentially putting together everything in terms of that, the code. So it's creating the wrapper, and then once it creates the wrapper, it's going to create the driver. There it is, there's the filter wheel driver. So it's going to create the driver, and then once it creates the driver, it's going to also create a bunch of other files within the repository. We're going to walk through everything, but essentially first we ask AI to build the driver. It builds the driver. Then we need to test the driver to make sure that it it's going to test out properly with the whole system. So the system is using Catch2, which is a C++ library to basically run tests against the whole repository. So when I designed this whole thing with AI and had AI help me build everything, basically I was trying to follow the best software standards possible for engineering all this. So again, we have a test system that we have. So like once it builds the driver and it creates this test driver or this test that we can test the driver against to make sure that it's not going to affect anything else in the repository, it'll test the software, make sure it's working. And then once it's working, then we build the software and then we connect to the actual hardware through the Alpaca HTTP that I've created. And then essentially once we get connected there, then we'll connect the hardware and make it all work. And I'll show you how to, it's very simple. Again, this is just, yeah, it takes time because I'm using a medium model. So it takes a lot more time of thinking and implementing all this stuff. So again, I'm going to pause it, but I just kind of wanted to update you on kind of like where we're at right now because it's still building. Okay, so I am paused it because here it is building the test filter wheel that we were talking about. So because it read all the documents that I've created within the repository by telling it to look at the agents file. The agents file gives it instructions to build the driver, to understand the SDKs, to understand the Alpaca API, to also build the test file. So it built the test file, and above here it also created the CMake file so that when we compile the software, it uses this CMake file to basically build the driver. So in here you can see it's gonna, where it points to the root external ZWO EFW to basically look at the SDK code and build the driver against the SDK code. It's really cool how this all comes together. Again, we're building the future right here, me and you. So now it's looking at the router. The router is the communication that's used on the Alpaca HTTP. I think that's on the core. The router is on the core system, and then basically the HTTP communicates with the core system to understand what pieces of hardware are available. So again, it's still building and doing everything. We're now at 12:26 on the time. So again, it takes time for all this stuff to build and set everything up. So it's going into the web app as well. There's a web application that I built on the Alpaca HTTP server that we can communicate with and basically set up all our drivers and everything. So again, I'm going to walk you through all this, but just kind of showing you like what it's doing and how it's going through it. So it just takes time for this because again, it's a medium model and it takes longer for it to all put together. So again, I'm just going to keep letting it build out. But you can see now we've already had 876 lines of code generated in less than 20 minutes. So that's pretty impressive. Now we're up to 889. So I'll let it keep doing its thing. And again, I'll unpause it once we're done with the build here. Okay, so at this point, it looks like it's completed everything. It's just finishing up the last checkings on the thinking, but it looks like it's basically generated 892 lines of code in under 15 minutes, which is pretty impressive. And what's going to even be more impressive is when this all works and I show you how this comes together now. It may not be flawless out of the gate, but that's why we have to do debugging and testing to make sure this all works. So it's not like we're just, oh, we just had AI build us drivers and we're going to release them and they're good to go. It doesn't work like that. There's a lot of steps that we have to step through to do this. So it looks like it's still thinking. There we go. So it finished it and it's just telling us exactly what it did. So essentially it built 10 files changed. It made a bunch of changes in the code. It created the wrapper, the driver. It updated the CMake file. It created the CPP and the H file. Those are files within the C++ libraries that have to communicate with one another to build the software. Oh, excuse me. We have the test ZWO filter, and then the router, the app, and then an index.html, which is like the base page that we see when we load the server. So pause here on the video and then come back and we'll continue from this point. Okay, so I'm back from lunch. It's 2:45. Had to run some errands and other stuff. So in here, we've got everything that's built. I may have clicked over here just to see, but essentially what's cool about GitHub and the way that it manages stuff as files are changing, it automatically keeps track of all those changes. I won't, again, go too deep into it, but just so you're aware, everything that we did, all the files that we created are all in here. So everything's good to go. So at this point, I'm going to open up Terminal and we're going to go ahead and run the test program that's built into AlpacaBridge so we can test to make sure that the electronic filter wheel is going to actually work properly within the code. This isn't us testing this the the hardware yet with the new driver that was written in 15 minutes. This is us testing to make sure that the driver works with the application properly. So in here, we're going to go to Documents, GitHub, AlpacaBridge. And then inside the default AlpacaBridge, if we do an ls, in here it's got everything. So I just downloaded this today, so we're going to have to do a chmod plus x on build.sh. And then we're going to have to do the same thing on the run alltest.sh we want. So in here, we're just going to do a / and then run all tests. And this is going to run through the test again to make sure that the driver is legitimate. So just checking to make sure everything looks good on my recording screen. So in here, it's just going to execute and check everything. So basically it's compiling the code and verifying that it's going to work properly with the tests. And it's running through all the tests, make sure everything looks good and everything passed. So basically that means everything's good. And then we can look in here to make sure that it actually did a test against the electronic filter wheel, which we can see it was in there. So it did do basically some testing on the electronic filter wheel. And then if we go up here to the top, we can check the other tests as well. So there it was again, the electronic filter wheel driver, disconnected behavior. It tested everything. It just made sure that it worked properly with the code. So at this point, we've verified everything is working. So what I'm going to do is I'm just going to switch over real quick to my phone, just so you can see that I've got, right next to me, I've got a Windows laptop here, and then I have a USB dongle right here for the Windows laptop, and then I have a USB dongle, and this is going back to my Mac. So I'm going to use this one to plug in real quick. So we'll go ahead and plug it in that we can test the software and actually see the filter wheel move. So actually, let me just go back to the screen with camera. So that's next to me on the side. I'm going to swing over to it in just a second. So now at this point, what we're going to do is we're going to build the whole software solution. So this is going to build everything. So this compiles the core system and then also the HTTP system. So it takes just a second to build out, and it's running. So at this point, we just want to open up our local host and go to port 6800. So I've got a browser over here. So we'll just pop over here and type in localhost. And this is Alpaca HTTP server. So essentially this is the server that's running our Alpaca. It's very simple. There's not a whole lot to it. There's not, I try to make the application as simplistic as possible. The big thing is the server info. As I update the code, it'll slowly update in revision numbers and stuff like that. So in here, you can put in your city and your state, because when we run Alpaca or the ASCOM ComformU tool, it checks all this stuff. So it wants to know what your location is. So you can put in a location and hit save. Whenever you save it, it creates a JSON file locally onto wherever you're running this application from. So if it's on a Raspberry Pi or Windows or Mac, it creates a JSON file of all the settings that we're going to configure. So in here, if you click on configure, we can go down to device type, and then we can choose filter wheel, and we're going to choose ZWO, and we're just going to add the device, and it automatically added it, and it brings you back to the main page. So it's listed here. So at this point, Alpaca, the front end basically is pulling a JSON file that it wrote to, and it's basically based on what we added. It added the filter wheel, and it's showing up in here. And essentially at this point, we could connect to this with Nina. So I'm on a Mac, and you're like, oh, you can't do that on a Mac, but I can. I installed what's called Crossover, and Crossover is an application that allows you to run Windows applications. So here's Nina coming up, and essentially once Nina comes up here, just takes a second to load. We should be able to go over here to the filter wheel and then hit the refresh button, and it should show the filter wheel listed in here. And there it is, the ZWO filter wheel. So we can click on it, and at this point we'll go ahead and connect, and it should connect, and there it is. We're connected to the filter wheel. Now, it doesn't have any filter names or anything like that because I haven't set that up. So what I'm gonna do is disconnect it, and then I'm gonna go ahead and here to options, and then equipment. I believe. It's been a while since I've done this. So I have 7 positions on here, so I'll just call them out. So L, what is it? LRGB. Geez, it's been a minute. LRG, G, and B. And then I have hydrogen, oxygen, and sulfur. So we'll come in here and hit sulfur, and then that'll save it. And then we can go back to equipment and then connect. And now it should show all my filter names, LRGB. So I'm going to switch the camera here real quick. And let me just make that a little smaller. So we'll just put this down here so we can actually see it in real time, that I'm not doing some kind of crazy nonsense. So I'm grabbing the light, I'm holding it so you can see the light behind the thing. And then essentially here on my screen, I'm going to just change the filter again. So we'll go down to, it's on red right now, so we'll go to sulfur and I'll hit change. And you can see it changing there in real time. And it's just changing back to red. And then we'll go back to luminance. So okay, so that's that. So let me just go ahead and remove that. So remove this. Okay. All right. So that's the filter wheel. We've got it all working with a driver that took 15 minutes to build with AI. So just remember that. So I'm going to go ahead and disconnect from it at this point. And then, so at this point, I'm going to just minimize Nina. As you can see, it's running over here, and here's crossover. This is the crossover application. I'm not telling you to make a purchase on it or anything like that, but that's how you can run Windows applications on an Apple. So we've verified that the driver is actually working now. And again, 15 minutes to build it. I haven't done anything else in here. As you can see, the code hasn't changed at all. I haven't sent any more working replies or anything like that. Again, because I've been working on this agent file and building it up, every single time that I build a new driver, I go back when I'm completed with everything and ask it to, is there anything that we missed? So we'll get there once we get there. So the next thing I have over here is the ConformU tool. So we'll go ahead and launch this. Okay, so I stopped the video real quick because I think it's important to understand what we're doing at this point. Let's back up a little bit just so we can get on the same page. So ASCOM created the standard that astronomy devices connect to and manage and work with, right? They created the standard. So this is how things are supposed to work within that standard. So what we're doing at this point is we're using ConformU, which is a tool that ASCOM created so you can verify that the drivers that you're building meet the ASCOM standard. So I know we're working on ASCOM Alpaca, but ASCOM is the standard. So for Windows, it's ASCOM COM, and for Alpaca, it's ASCOM Alpaca. And again, Alpaca is, I didn't spend time explaining all this stuff. I cut it out of the video because it was just way too long. But to understand ASCOM Alpaca is essentially, it's the future of ASCOM COM, which ran on Windows, and ASCOM Alpaca works on all flavors of the operating system, right? It works on Windows, Linux, and Mac. And essentially what we're doing at this point in the video is we're taking ASCOM ConformU, which is the tool to verify that your driver works properly. So this isn't like some magic AI thing that I'm doing, right? I'm using AI to build the driver using the agents file. And then once we get the driver working and tested that it actually moves the hardware within Nina, then we're going to use ConformU to verify that the driver meets the standard of ASCOM. So I hope that makes sense, right? Let's put that together real quick. ASCOM built the standard. They built the tool ConformU. When vendors build drivers, they're supposed to build drivers based on the ConformU tool to make sure that it's certified to work with the ASCOM standard. We're doing the exact same thing, except we're using AI, and we're building the drivers using SDKs from the vendors or RS-232 files for mounts or other things that vendors give us so that we can build these drivers properly. So that's what makes this tool so powerful. And I hope you're kind of it's sinking in. So let's jump back in. And it comes over here, and then we'll select the device, and then essentially it should find the device once we move to the focuser. Should. That's not the focuser. We're on the filter wheel. There we go. Helps when you choose the right device. So in here, it automatically sees the system as the electronic filter wheel, which is 1.206, which is this local computer. So just to show you, let's go to terminal and then a new window. And I think it's ifconfig. It's 192.168.1.206, which was one of them. 1.206. So as you can see, that's the local computer. So again, it's right here. That's my IP address, 192.168.1.206. So again, I'm running the Alpaca server on Apple. And we can connect to it through any web device or anything like that. So as a matter of fact, let me switch over to my iPhone real quick. Just so you can see, I'm going to boot up my Windows box. So let me just boot this thing up real quick. Good old Dell. Go Dell. And I'll log in real quick with my tippy top secret password or my fingerprint. So we're all here to go. I've got a bunch of stuff on the desktop on here that you can see. So I'm just going to do a little RDP session from the Apple. So let me switch back over to screen and camera. So on here, I've got, whoops, wrong one. It's this one right here, Windows app. So in here, I'm just going to reconnect over here to the Windows box. So I have a Windows computer to look at. And as you can see, I'm on the Windows computer. And then on here, if I open up a browser, so we'll just open up Brave real quick. And then that's Conform. So we'll just go to, it's okay, we can just type in the IP address, 192.168.1.206. And there you go. There's the server. Filter wheel, and it shows everything. So as you can tell, I'm not just faking you guys out. I'm on an actual Windows computer, which is this laptop right next to me. And essentially I've got everything set up here so I can actually hit the server from the 206. So I'm just going to minimize that for now because we are going to use this box in a minute. So in here, I'm going to go back and add iPhone. So we'll just add that real quick. Move that down and we'll just set it over here so it's kind of out of the way. And then we'll move this over just a bit. So in here, I basically have Conform set up, and essentially I've connected to it and everything like that. So I'm connected to Conform. It runs locally. And if we go to the home button, this is where you can start the test to do the Conform test. And this is, again, this is ASCOM software that's been created by the ASCOM developing team and the ASCOM initiative. And essentially this allows you to verify if a driver is certified. So if you're listening to me, ZWO or iOptron or any other vendor that's watching this video potentially, you can use this tool to make sure that your Windows ASCOM driver meets the standards of ASCOM framework. It's really great and it works wonderful. So we're going to go ahead and start and let it run through its test and see what happens here. So it's essentially running through the test. It's also got like a text mode over here as well that runs as well, but we're just going to go through and run through it. And then as you can see, the filter's changing over here in the bottom window. I don't know if you can hear it or not because of my mic, but it's just checking to make sure that it works. So we can already see there's issues here with the names and all that. So there's some stuff that we're going to have to work on to fix within the driver, but that's okay. That's part of this debugging that I was telling you about that you have to do to make sure that the driver meets Conform completely, like everything's good to go. So definitely we're having some issues right here because it doesn't have names. So we have to figure out how to get the names. So we'll work on that here, like I said, in a second. So it takes a moment for these tests to run. So I'll just let it run through the whole test. Okay, cool. So congratulations, all members returned within their target response time. So this is good. So all these things are part of the standard test that basically ASCOM feels are important. And this is really important to get these all down. As I've built stuff, like when I was building iOptron, some of these weren't working properly. So I had to go back in and basically debug the code. But we have some issues here. So the issues where the names get. So basically what happened is it was trying to get the name of the filter, but it couldn't grab the name of the filter. So it wasn't pulling that name. So we need to work on fixing that. So essentially what I'm going to do is just highlight this whole text and then click on it, and then we're going to swing back over to basically cursor and using Codex again, and just say I ran the conform test, conform test. We need to fix some issues, and then I just paste the whole. Oh my gosh! Hold on, and then so this is the whole thing. I pasted everything. I accidentally closed it out. So again, this is going to take a moment to think about. It's got to go through and just figure out what's wrong with it, why it wasn't working properly. It goes back and it checks all the API information, and then also the error log. And then in here, you can also see there was some errors as well. So yeah, here it's already pushing some stuff about the names and creating the names and stuff like that, and information about the names. So it just fixes all the code. Okay, so here we go. Adjusted the filter wheel driver to match the conform expectations, removed non-operational connected from device state, and ensured filter names are never empty by defaulting to filter 1, 2, etc. I aligned with ZWO unit tests with the new device behavior. Device state now emits connected for filter, and then default filter names are applied whenever names are empty in a newly created in. So this is what I'm going to ask a question is should we, and again, I'm just doing this based on building drivers and just kind of thinking about things. I worked initially on another project called Alpaca Pi Server, and Mark Sproul is the creator of that project, an amazing project. If you haven't checked it out, it works really well. He's basically doing the same thing that we're trying to get done here with AlpacaBridge, except he has his own special, unique applications that he's built to control all the devices. My goal of this software was to just give you the Alpaca standard straight up, and then basically you bring your own software. So if you want to use Nina or SGP or anything else that's Alpaca compliant, you can use it. So in doing that, when Mark originally built the software, he had a config file that had all the filter names in it. So thinking about this out loud, just so you're aware, I want to create it so that when you load the web page, you can load all the names of the filters on the web page when you're building out the driver. So I'm going to ask AI that. So should we configure the website to allow users to add filter names? So I'm going to leave it up to AI to do this. It doesn't matter to me if it's a CSV or JSON or whatever. I'll let it make its choice. It's not going to affect it at all. It's just a web interface that basically is going to allow us to build what we need to build. So in here, another thing that I didn't show about Alpaca HTTP, we didn't mention it, but it's here. You can actually shut down the server. So because we're going to be making changes to the server, or AI is, and making some changes, I'm just going to shut down the server so we can restart the server up and then essentially run it. So over here, it shuts down the server, and then as you can see over here, it brought it down on the essentially the command line. So we'll see where it's at. It's still thinking and doing stuff. So it's editing the index file. And it's editing the app.js. So there's a JS file that runs that allows the web page to function properly and allows you to input information based on drivers and stuff. So just take a second here for this to build. Okay, so it's good. All right, so it added everything, added a filter name input for the filters and all that. So what we'll do is we'll just hit the up arrow. And then it'll do the build run again. So it's going to build and compile the whole software again and get everything set up. And then we can go back to the host and then configure everything. All right, so it's running now. Refresh. And then we've got Alpaca here. So I'm going to delete this because there's some changes that have been made to the configuration. So the cool thing is that like if you run this software, as soon as you set up all your devices and they're all configured, they're in here, and then you can just easily add and delete or edit devices as you need to. So in here in the configure, we'll just go back down again to filter wheel and then select the vendor, ZWO. And then in here, it lets us put in the filter names. So in here, I'm just going to type in the name. So luminance, LRGB, ZWO. All right, add device. Filter wheel not connected, but it is. So, all right, so I'll just give it this error. And creating the new device. Oh, that's all right. That's the nice thing about AI. You don't have to type perfectly. I said it have me an error when creating the new device, but it knows. It's smart enough to understand that my English is extremely poor when it comes to typing, and it figured it out. So it'll fix it here. So again, we're going to go back and just shut down the server again. And then we'll start it up here in just a second once it's done building. Okay, so it fixed it real quick. Error happens because the UI config path calls set name, so it knows. So we'll go ahead and run it again. So all right, then refresh. And then we'll add the device. So filter wheel, ZWO, and then we'll put in all the filter names, L, R, G, B, S, H, O. Anyways, here you can see the filters rotating, as you can see it down here in the corner. And I don't even really need that light, I don't think. Whoa, sorry. Let's not create anybody with with anybody that can't handle that stuff. So in here, you can see the names now are working. So it was able to get the filter names for the info. So it did find filter names. It doesn't, I guess it doesn't care what the filter name really is. It just grabbed it, filter 1, 2, 3, 4, 5, 6, 7. So I am going to ask it, AI, about these filter names. I set up the names as LR, L, it just doesn't matter, LR, GPS, HOS, but when running the conform report, conform report, it's not showing the actual names. Is this correct? Okay. And then in here, we'll just check to see it should be fine. But in here, if there was any issues with the driver, like there was errors, it would say in here there was drivers. And it right here, you can see congratulations, no errors, warnings, or issues found. Your driver passes ASCOM validation. This is a validated drive in 15 minutes in like maybe 10 minutes of debugging potentially. Now, we're not done yet. We still have a little more to do, but we'll just let AI do its thing and figure out what's going on with the naming. Right now, the configured names were getting cleared during the initial disconnect cycle that ConformU runs, so it fell back to the default names. So now the driver is going to be a little more effective. So at this point, what we'll do is we'll close out of conform. We'll go ahead and we don't need to worry about deleting this because it didn't make a change to the initial thing. It's just making a change to the driver. So we'll just shut down the server and hit OK. And then at this point, we'll go ahead and relaunch the server and rerun it again. So it's just going to run the server real quick and get it all set up. We'll go ahead and hit refresh and everything should be there. So anyways, so we got everything set up here, LRGBHOS. So we'll go ahead and we'll pull up conform again. And then again, the device is already selected and we'll just start. So at this point, it's going through and checking. Ah, there we go. There's all the filter names now. So now it's finally getting all the filter names and listing them properly inside conform. So at this point, our driver is essentially certified, but it's not 100% yet. And I say it's not 100% yet because I want to essentially plug in the filter wheel into Windows and then use the Windows computer to essentially do conform against the ASCOM driver to make sure that the actual ASCOM driver isn't better or is lacking features that the Alpaca's not. I'm sorry. Let me try to rephrase that. I want to make sure that the Alpaca driver is basically meeting everything that's supposed to be in the ASCOM driver that the vendor's putting out, right? The vendor's the one that that created the SDK. They're the one that created the driver for Windows. So I want to make sure that if they have extra features that we may not know about, that we're making sure that the drivers are aligned, and or even better than the ASCOM drivers. So at this point, it completed the test. There are absolutely no errors in the validation. Also, it knows which filters are which. LRGB HOS is what I put in, so it even is grabbing the names of the filters and listing it in the conform test. And again, I did all this debugging with AI and just prompting it, hey, do this, hey, do that. Here's the error, fix the error, and it's fixing it. So I have this whole screen. I haven't modified anything in here. I just started with the whole first conversation. I want to build a new driver. And went in and built the new driver. And then I ran the conform test after we tested the driver and gave it the error logs. And then essentially at this point, it's adjusted some changes in it and adjusted some more changes. And then we gave it the log again and adjusted some more changes. And then it fixed the driver again. And now we're at this point where we're ready to go with everything. So at this point, again, it took about 15 minutes to build the driver initially with AI. AI built the driver enough that we were able to execute and connect to it. And then maybe another 10 or 15 minutes of debugging to fix it. So I've built an actual running ASCOM ComformU compliant driver for Alpaca in less than 30 minutes. It's insane. That's why I'm saying like this is the future of astrophotography, and I'm really trying to bring that home to show you how quickly you can get this all done with AI. So if I had another mount or something and I had the SDK for it, I could easily build another driver and keep going. So with that, let me hop into Windows real quick. So over here, I'm in Windows. So I'm going to go ahead and disconnect that USB cable from the Mac. And then I'm going to connect in the one from Windows. So there it is. So now we're back into, this is connected to Windows. And then in here, what I'll do is I will open up ConformU on the Windows box. And let me just move this window over right here. And then we'll select the device. And then in here, we're going to choose the filter wheel. And then in here, we're going to choose the ZWO ASCOM filter wheel because it's already going to see it because I've installed all the drivers. So in here, if I go to the control panel real quick, God, I hate Windows 11 sometimes. So much easier in Windows 10 to right click and go to the control panel. But anyways, if in here in system and security, geez, under programs, so in here under the programs and features, I've got ASCOM installed 7.1, ASTAP, Bitdefender, all kinds of other stuff, PHD2, and then all the drivers, and then ZWO drivers and camera drivers and all that. So everything's in here. This is essentially Windows basically set up for ASCOM. And the reason why is because we need to test the driver in ASCOM. So at this point, I'm going to go ahead and start, and then essentially we're going to test the driver to see how good the driver is. So it's going to go through. It's showing that it's natively connecting. It found that it's a filter. It doesn't have the filter names for the get names. It looks like name one. Oh, I guess it has some kind of base name that it throws in the driver. So name 1, 2, 3, 4, 5, 6, 7. And it's going to go through and test everything. So it's going to go through the initial tests. And you can see it moving over here in the other screen. So and it's cool too if you go through this and actually like see what's getting tested, right? So in here you're testing the sequential movement, the descending, the ascending, and then also potentially long distance moves and stuff like that. So everything's good. Congratulations, no errors. Your driver passes ASCOM. Everything looks good. Uh-oh, one member took longer than the normal response time. So there's a problem with the ZWO driver. It's not right. So, so in here, this driver is not 100% ASCOM compliant because it took longer than it should have for the names. So the names should have been quicker. So there's something in the driver that ZWO can correct. And I'll just let the cat out of the bag because I'm just going to. If you test your equipment that you own and run this ConformU test, you'll find out how good of a vendor you have or how bad of a vendor you have. I'm not going to say anything else other than that. I'll leave it up to you to test your own drivers to see how good your vendors are in the Windows realm for ASCOM drivers. And that to me is the biggest excitement about this, is that every single driver that I'm going to be releasing under AlpacaBridge will be 100% ASCOM compliant, meaning it has been verified by ASCOM ConformU tool that this driver works and meets the basically the astronomy standard to a T, to a perfect T, all with AI, and in building it in 15 minutes. How about that? Put that in your pipe and smoke it. So we're going to leave this as is. What I'm going to do is I will grab the driver logs from here, and then I'm going to bring them back over to the Mac, and then have AI compare the two drivers and just make sure there's nothing lacking. So instead of me like going through the file one by one, I can just have it easily grep the files and look at it and see if there's any differences. So in here again, documents, there's an ASCOM folder, and then in here there's a log folder. So today is the 10th. So here it is. So there is 2 logs in here. Let me just close out of ASCOM just to make sure that everything got created properly, and then it creates all the files. So let me just close that too. And then we'll just refresh real quick. Refresh. Okay, so there you go. So there's the ASCOM driver, and here's everything that's in here, so we can go back and look at it real quick. And if we go to the bottom, one member took longer than its normal target time. So we'll just copy this file and we'll paste it over here on the Mac, so it's on the desktop. And we'll just minimize this for now. And then what I'm going to do is I think I only have one Finder window open. I do. So I'm going to open up a new Finder window. And this is the next part of moving the logs over, because we've verified that it's completely working the way that it's supposed to now. But we want to test it real quick. So I'll just move this log in here, and then I'm going to let it know where the logs are. Can you please, and I usually put a W in here so we know for sure that this is the Windows driver. So I'll just put a W dash and then the name ASCOM, just so we know it's Windows, and the other 2 are from Alpaca. So, excuse me, can you please please look at the conform reports and check the difference in features and see if our driver is lacking. The Windows log is starts with a W dash, and the Alpaca is lowercase. The files are located in documents slash GitHub. Oh no, sorry, documents. I think it's documents ASCOM, right? Documents ASCOM, yeah. ASCOM slash, we'll just grab the file name. Okay, so basically I'm just asking AI to look at both of our reports from ASCOM ConformU for Alpaca and for Windows, and basically comparing to see if anything in the Windows is better or features that we're missing in the Alpaca driver. So we'll have it come back here and see if there's any differences that are things that we need, that we may have missed, that we can make sure with AI. So that way we know for sure that our driver is at least working and has the features that Windows has, and or is better because ours doesn't have that one error message in it. And again, like I said, I'm not going to let the cat out of the bag on vendors, but I'm just saying, check your vendors, check how compliant their drivers are, and you will be amazed. So let's see here. So it basically says I compared the 2 conform logs. The key differences from Windows COM to Alpaca interface version. Windows is version 2, Alpaca is version 3. We don't care. That's expected and that's normal. Device state, Windows omits it. Not available in this interface version. Alpaca reports position. That's correct for version 3. So it's working right. Driver identity strings, Windows reports name equals ZWO filter wheel, ZWO filter wheel 1, driver ZWO, whatever. Alpaca reports Alpaca core strings, which is fine. Filter names, Windows shows 1 through 7. Alpaca log shows LRGBHSO, which is what we wanted it to do. So the Alpaca log you sent, the custom names are applied. Timing Windows names was slower than the fast target. Alpaca meets timing, so our timing is correct, meaning when ASCOM is designing this tool, the ConformU tool, they basically have timings, so they're expecting things to move at a certain rate, and if they don't meet that rate, then they don't meet the standard. So essentially what that means is that the hardware does meet the standard of what it's supposed to move at, but the software for the ZWO, their timing is off. So ZWO needs to go back and correct their driver is what that means. So Connect model, Windows uses only connected. Alpaca supports Connect plus connected external differences, which is that. So conclusion, your Alpaca driver isn't missing features relative to the Windows COM driver. It usually, it's actually exposing more device states because it's interface version 3. Okay, so I went ahead and just stopped the video at this point. There's a lot of stuff I'd like to go over and show you, but I think the biggest takeaway for this is it took 15 minutes to build a driver for ASCOM and a little bit of time to debug the driver to make sure that it was ASCOM compliant. I think in that itself is enough to show you that this is the future of astronomy. We're building drivers better than vendors are building drivers, and they're open sourced for everybody to use. So my hope with this video is that you'll hop on, download the source code, and download your SDK or your RS-32 sheet from your vendor and work on building a driver and test it out and make sure it works. And then push back your changes through a pull request. Again, if you don't know all this stuff and you don't know how repos work, don't know how GitHub works, there'll be links down below in the description. I'll try to find some good videos to post that aren't mine, just other people that have shared how they use GitHub. Again, I think this is a really cool time that we're living in with technology that we can use AI to help us build stuff if done properly. Clearly, it's not the be-all, end-all. It's not perfect. But in this session that you saw me work through, it was pretty quick and pretty seamless because I've spent so much time working on building up that agents file. So with that, I wish you the best. Clear skies. Until next time. See ya.